So let's just have a go then at the second of our tricky A-level maths exam questions. Now, as we can see for this question here, quite a lot going on, so let's just read this and go step by step. So for this question here then, as we can see, right, the stopping distance of a car in an emergency Y meters when driving at a speed of X miles per hour is given by this quadratic equation here, where A, B, and C are just constants, okay? We're also given the following information here, which just gives us the stopping distance for a particular car, okay? As we can see here then, we have the 3 bullet points. And then for the first part of the question here, part A, all we want to do then is find the values of A, B, and C. Okay, so let's just start with part A then underneath here. Okay, now where can we really begin with this question here? Like I said, there's quite a lot going on, and I think probably the most challenging part is kind of deducing where we actually begin with the question. But to begin with here, what I'm going to do then is I'm just going to form some simultaneous equations. Okay, so pretty similar to the previous question here, we just begin then by forming simultaneous equations. Now, how do we do that? Well, we just use this information here. So we know then that it takes 11 meters to stop when driving at 20 miles per hour, 33 meters at 40 miles per hour, and then 63 meters at 60 miles per hour. Okay. So based on that information then, and using this equation here, let's just highlight this equation here. Then in that case, given that y is the stopping distance, we get 11. So we have 11 is equal to ax squared. So x here is the speed that we're driving at, so 20 miles per hour. So 20 squared is 400. So in that case, then I get 400a. So 400a plus 20b plus c. Okay, that's our first equation. Let's just label that as equation 1. We then have our second equation here. So y is 33. And this is equal to, so I get 40 squared here. So 40 squared is 1,600. So we get 1,600a plus 40b plus c. And this second equation here, let's just label that as equation 2. And then finally here, we have the very last equation then. So 63 meters to stop when driving at 60 miles per hour. So in that case then, 60 squared here is 3,600. So I've got 63 is equal to 3,600. That's 3,600a plus 60b plus c. Okay. And this final equation here then, let's just obviously label that as equation 3. Okay. So what I've got here then is my simultaneous equations. Okay. Now, what I need to do then here is obviously just solve these simultaneous equations, right? Once we solve these simultaneous equations, that will give us a value of a, b, and c. But how do we actually solve these simultaneous equations here? Well, what I'm going to do then, given that I have a plus c here, a plus c here, and a plus c here, is just rearrange then equation 1. It doesn't have to be equation 1, but I think it makes sense to just do equation 1. I'm going to rearrange equation 1 here, making c the subject, and then just substitute that into equations 2 and 3. Okay, so let's just do that over here. So if we just rearrange then equation 1, making c the subject here, what do we actually get then? So c here is equal to, so we get 11 minus 400a. So 11 minus 400a minus 20b. Like so, there's nothing else there, right? So c is equal to 11 minus 400a minus 20b. Perfect. Okay. And at this point here then, all we now need to do is just substitute this rearranged form of equation 1 here for c into both equation 2 and equation 3, right? So if we just do that underneath here then, starting off with equation 2, what do we get then? So I have 33 is equal to 1,600a plus 40b. And then we have plus c here, where c is 11 minus 400a minus 20b. Okay, so altogether then, plus 11 minus 400a minus 20b. Okay, so that's equation 2. Now, clearly we can simplify that. We'll come back to that in a moment. And then for equation 3 here, let's just do the same then. So we get 63. So 63 is equal to 3600a plus 60b plus c, where again, c is 11 minus 400a minus 20b. Okay, so plus 11 minus 400a minus 20b. Okay, so let's just simplify equation 2 and equation 3 here. So for equation 2, then what do we get here? So 33 minus 11 is 22. To get 22 is equal to, so 1600a minus 400a, that's 1200a. So 1200a here. And then finally 40b minus 20b, that just gives us plus 20b here. Okay, so that there is fully simplified. We can't do anything else with that, so that's perfect. Doing the same here then with equation 3. So 63 minus 11, that gives us 52. So 52 then is equal to, so 3600 minus 400, that gives us 3200. That's for A, right? 60b minus 20b, that is plus 40b there. Okay, and then hopefully at this point here, right, pretty straightforward. All I now need to do here is just solve these simultaneous equations, right? A couple of different ways you can do this. You could just use substitution, or alternatively, we can just use elimination, right? So pretty straightforward. If I just times the top equation here by 2, and then just eliminate here. So we're eliminating b, solve for a here. Should hopefully be pretty straightforward, right? So if you times this by 2 here, what we get then is 44 is equal to 2400a plus 40b. And like we just said then, eliminate here for b, so we can go on to solve for a. So what you should get here then, I won't go through all of the working for the simultaneous equations. This should be pretty straightforward, right? Just basic GCSE maths at this point here. What we get then is 800a is equal to 8. And then clearly, right, we just want a here. All we need to do then is just divide both sides by 800. In that case, then we get a is equal to 1 over 100. Or alternatively, 0.01 there. Okay, so that's A. So what about B then? Well, if we just go back to either of these two equations here, it's completely up to you which one you use, but let's just substitute into either of these two equations. In that case then, what I'm going to get here, so for B, let's do that over here. So for B, we'll use this equation here. So in that case then, 22 is equal to 1200 times by 1 over 100. So that's 1200 over 100 plus 20b. So plus 20b there. So 1200 over 100 is 12. What I've got here then is 20b is equal to, so this would be 22 minus 12, which is 10. And then finally, right, if we just want to solve for b here, just divide both sides by 20. Nice and straightforward then. You just get b is equal to a half, right? So b is equal to 1 over 2. And then finally here for c, well, c is equal to 11 minus 400a minus 20b. Okay, we'll do that over here. So for c then, so as we just said then, using this equation here, we get 11 minus 400 times by 1 over 100, so that's 400 over 100, minus 20b, so that's minus 20 times a half. Okay, if we simplify this here then, what do we get? So I've got 11 minus 400 over 100, so that's 11 minus 4, minus 20 times a half, so that's minus 10 here. Okay, so 11 minus 4 minus 10, so that gives me minus 3 there. Perfect. And that's for C here. Okay. So for the first part of this question here, I appreciate as well that this has took quite a bit of time. Like I said, these are tricky A-level maths exam questions. So let's just state here underneath then the values of A, B, and C. So A then is equal to 1 over 100. B is equal to half here. And then finally for C, what did we get here? We got -3, right? So C is equal to -3. And there we have it. So that gives us the solution to the first part of this tricky A-level maths question here. So that's part A done. Let's just quickly clear the screen and have a go at part B. So as you can see then, we've now cleared the screen. And what I've also included here is this equation for y, right? And this equation for y is based on the values of A, B, and C that we found in part A. Okay? Now just a quick disclaimer here, and I should have mentioned it at the start of the question as opposed to now when we're starting part B, but it should say at the bottom of this question here, or at the top, doesn't really matter. It should say then that solutions based entirely on calculator technology are not permitted. So basically all that's telling you here then is you can't just input all of this here into a calculator, the simultaneous equations part of your calculator, press enter and get these solutions for A, B, and C. Basically, we do need to show full working here. So how we did the solution in part A is how you also need to present the solution as well. Okay, just a quick disclaimer there. It doesn't really apply to part B as such, but there you go. So let's just get started with part B then. So for part B here, it says given that a car has a stopping distance of 21 meters, find the speed of the car. Okay, so for part B then, let's just do that over here. So for part B then, we now have a stopping distance of 21 meters. So I've got this quadratic equation here, okay? So what I'm going to do then is set this quadratic here equal to 21, just replacing y with 21, right? Because y here is the stopping distance, okay? So what I get here then is 1 over 100 x squared. I've got plus bx here, where b is a half, so a half x, like so. And then finally -3 here, and all of this is equal to 21, okay? Now, if we're going to attempt to solve this quadratic here, this coefficient of 1 over 100 isn't nice, right? So to alleviate that problem, all we do here is just times 3 by 100, okay? So if we do that then, what we get here is x squared. So we get x squared. 100 times a half here is 50, right? So I get plus 50x. -3 times 100 here. Oh, sorry. Before I do that, subtract the 21 off both sides here as well. Okay, so -24. And then times -24 by 100, that's -2,400. Perfect. And this here then is all equal to 0. So I just kind of forgot the step in between there. All I've done is just subtracted 21 off both sides. Okay. So now what I've got here then is a quadratic equation where one side is equal to 0. So what we want to do here then is attempt to solve this quadratic. So the hope here is that this factorizes. And the good news is this does indeed factorize. It always saves us a little bit of pain here if the quadratic will factorize. So in this case here then, what do we actually get? So obviously we're going to get double brackets here then. We'll get x plus 80. So x plus 80. And x minus 30. Okay. And all of this here then is equal to 0. Okay. Now clearly then, this gives me two solutions for x here. I get x equals -80. So x is equal to -80. And we also get x equals 30. Now clearly this solution here is a problem, given that x represents speed, so it's miles per hour. I can't be going at -80 miles per hour here. So we don't include that solution. Obviously this is my solution here. Okay. And then finally to finish with here then, let's just state the speed of the car. So in that case then, the speed of the car here. So the speed of the car is 30 miles per hour. Okay. So 30 miles per hour there. And there we have it. So that gives the solution then to the second here of our tricky A-level maths exam questions. And as always, Thanks for watching.